Hi there, my name is Matthew and welcome to the second episode of the Ringing Rabbit Hole. In the last episode we went over the structure of a method, but today I want to talk about how calls work. If you haven't seen the previous episode and don't understand the concept of place bells, I'd recommend you watch that episode first. A call occurs whenever the conductor shouts bob or single in order to change what each bell does next. A call can happen at the end of any lead and typically modifies the lead end change. For example, in plain bob doubles, if a bob was called here, then instead of doing this lead end change, you would do this change. This then modifies the lead head of the next lead and so changes what the bells are doing next. So let's look at what you have to do when there's a call in plain bob doubles and why. If you were a 5th place bell, you are normally about to dodge 3-4 up and become 3rd place bell. If a bob is called, you instead make a place at the lead end change. This makes you 4th place bell, and 4th place bell starts by hunting in and then doing 4 blows behind. So essentially, this is your line. You make 4ths, hunt back in, and then do 4 blows behind next time. This pattern is known as making the bob. You have, in effect, started doing what the 2 would have done if there was no call. For the rest of the line, where you would have seen the 2, you will instead see the 5. If you are 3rd place bell, instead of making seconds you hunt out and become 3rd place bell again, and so make seconds next time. If you are 2nd place bell, instead of dodging 3-4 down, you hunt in and become 2nd place bell again. Thus, it is as if you were finishing making seconds and so do 3-4 down next time. Finally, if you are 4th place bell, the call does not affect you, and so since your place bell has not changed, you just do what you would have done normally. All of these changes can be visualised in our circle of work with this transition instead of the normal rotation. Notice how the bell which is doing 4 blows behind still does its normal rotation as it is unaffected. Before going any further, I want to get you comfortable with the concept of permutations, as they can be a big shortcut when dealing with calls. I mentioned in the previous episode that a single lead shuffles around the bells in a very specific way, and that since the path the bells take in each lead is the same, you can just apply the shuffle again to get the next lead head. This set of lines describing how to move the bells around is known as a permutation. If you have a set of changes, you can ignore the rows in between the start and the end and just use a permutation to tell you what the result of these changes are for any initial row. You can also do this in reverse, working out what starting row to have to get the final row. If you know the permutations for a plain, bob and single lead, you can easily check through a whole composition just by transposing the lead heads. This prevents you having to write out all the rows inside the leads. In this visualization, I am only showing the lead head of each lead in a composition. A white arrow represents a plain lead and a blue arrow represents a lead where a bob is called near the end. To get from one lead head to the next, I have used transpositions. This cycle shows the lead heads we cycle through with just plain leads. If we add a bob and continue having plain leads, you can see that we have entered a new cycle and are unable to get back to rounds without a new call. This new cycle is known as a course, and each course can be thought of as the method, but if it started with a different row instead of rounds. Each course has a course head, and for the normal course, known as the plain course, the course head is just rounds. However, in this new course, the course head is the lead head where the observation bell is in its natural position, where it was at the start. The observation bell is a bell whose path is used to remember where to shout calls. It is typically the heaviest bell, and so in this case it is the 5. It doesn't matter which lead we start a course from, it is still the same course. Looking closer at this diagram, remember that whenever we have a lead with a bob in it, the bell in 4th place is unaffected, but all the other bells swap around. These 2 rows represent the effect of a plain and a bob lead on this row. Note that the bell which is in 4th place, the 3, is in the same place for both as it is unaffected, so it will do the same work with or without a call. Looking at the next lead, notice how this shows us quite clearly which bells were affected by the call and how. The 4 has started doing what the 2 would have done, the 5 has started doing what the 4 would have done, and the 2 has started doing what the 5 would have done, while the 3 remains unaffected. This row, which is the equivalent of rounds in the new course, can be very useful when creating compositions and is linked closely to coursing order. If we instead had a call such that the 5 was unaffected, we would end up with the 5 in its natural position in this row, and so the rounds equivalent would be our course head. To ensure that the 5 was unaffected, I made sure to add a bob when it was in 4th place. For compositions on more bells, it is often the case that the rounds equivalent is the course head, as the tenors are often left unaffected. This means that the course head can be used for looking at how the bells swap with calls. The reason we have the course head defined as being the row with the observation bell in its natural position, instead of just using the rounds equivalent, is that it allows us to uniquely define the course head of each course. Otherwise, we could have two courses which are identical, but defined by different course heads. For example, this could allow us to define a course with this row as the course head, despite this course being identical to the plain course. Now, something to note is that the original course isn't the only one which contains rounds, and any row of a lead could be rounds if we pick the right course head. Note that to have a course head which we can actually get to using normal calls, we must pick a row with the treble leading. This row has a treble leading, so let's try and find a course with that row as rounds. Let's find what rounds would have to be to make that row rounds. In the plain course, this permutation is used to get from rounds to that row, so we can apply this permutation in reverse to rounds to find what that row would need to be. If we show the method starting from this row, you can see that we get to rounds where we expected. We can find the course head of this new course by looking for the lead head with the observation bell in its natural position, which is this row here. And you might think that doing this process on one of the other rows with the treble leading will give us a new course which also contains rounds, however that does not work. It instead gives us the same course, just with rounds being a different lead head of that course, and since the course is uniquely defined by the course head, these are the same courses. The reasoning behind this is quite complicated, but if you're interested, I'll put the reason on the screen now. The effect of all of this is that to successfully call a touch of a method, you need to navigate these course heads to get you back to rounds, while not repeating any row too many times, and getting some nice musical rows. It is possible to end a composition at a set of rounds which isn't a lead head, as we have shown, but this is less common. To keep track of where to shout calls, conductors could use calling positions. Each lead has a different calling position, which describes where the observation bell would be at the lead head of the next lead should a call be made. There could be multiple different names for the same calling position. For example, here, out could also be called before. By default, calling positions refer to where the observation bell would end up with a bob. When thinking about singles, the same name would refer to a different position depending on where the single takes the observation bell. If with the call, the observation bell ends up in the last place, it is known as a call at home. If you end up at a place 1 from the back, the name changes depending on if we have an even or odd number of bells. Since we have an odd number of bells, it is known as a middle. If we instead had an even number of bells, it would be known as a wrong. If you end up at a place 2 from the back, it is the opposite, a middle for an even stage and a wrong for an odd stage. This definition isn't perfectly agreed upon, and some publications may treat middle as always being 2 from the back, and wrong as always being 1 from the back, so be careful. The reason for swapping these around is quite subtle, and I'll explain it in more detail in the future. Next is before. If your bell ends up in first place and the call does not have a bell making seconds place, this is known as before. On 5 bells, this is the same as wrong, but for larger stages, these describe different positions. If a bell is making seconds place and you end up in seconds place, then it is also before. Thus, for common treble patterns, this means that before is when you are leading before the treble. The rest of the calling positions are quite simple. In is if you end up in seconds place, and out is if you end up in thirds place. Note that out does not have the same caveat as before. All other calling positions are just the number of the place where your bell ends up, thirds, fourths, fifths, and so on. Other number calling positions on higher stages are less common, as they can lead to calls which affect the heavier bells. Let's look at a simple composition for plain bob doubles. This is the form typically used to show compositions. Calling positions are shown at the top, bobs are shown with dashes, and singles are shown with an S. A number represents that many bobs, and when you have multiple calls at the same calling position, you can put them in the same cell. The calling positions at the top are shown in the order which they come up in during a plain course, assuming the heaviest bell is the observation bell. Only the calling positions used are shown. If multiple names for the same position are used, they are just put next to each other. The column on the left shows the course head we get to after all the calls on that row, with the treble omitted for conciseness. If a row on the left is bracketed, it means that we don't ring that row when in that course. Take this composition for example. Remember earlier when we found that the lead starting with 1, 3, 2, 5, 4 contained rounds before the next lead head? Since we have that lead here, we get back to rounds and thus the composition finishes before we reach this course head, meaning it is bracketed. In compositions with more bells, the heavier bells are often unaffected by calls, and thus if a row has the same back bells as the last non-bracketed row, we omit them. The front 6 are never omitted, which is why we didn't have any shorter rows before. This composition is often referred to as in, out, make the bob, as the call at middle involves making the bob, and this can help you remember what work you do at each call as a conductor, assuming you are ringing the observation bell. Typically the observation bell is the tenor, so as we ring this method we will shout bob when we would do 3/4 down, as the bob makes us instead go in. We would then shout bob when we would make seconds, as the bob makes us instead go out. Finally, we shout bob when we would do 3/4 up, as the bob makes us make the bob and end up in the middle position. After all of this, we would end up in the plain course, and thus with rounds. An extent is defined as the complete set of possible rows for a given set of bells. For example, this is all the rows in an extent with 5 bells. The number of rows in an extent is the factorial of the number of bells. If you haven't seen the factorial function before, it is just the product of all numbers less than or equal to the input number. For example, 5 factorial is 5 times 4 times 3 times 2 times 1, giving us 120. To derive this formula, consider that to create a random row, we have 5 options for the number we put in the first position, then 4 options for the second position, and so on. A composition is true if it contains a number of extents, not necessarily one after another, and any additional rows are distinct. The proof of truth for a composition can get pretty complicated, but know that the in-out make the bob composition was true, as it contained a single extent and nothing more. Bobs typically swap around the work of 3 bells, while singles typically swap around the work of only 2 bells. Here I am showing the lead end changes for plain bob minor, with and without calls. I have highlighted in blue the bells which are affected by the calls, and are thus in a different place to where they would be without a call. Notice how for a single, in order to affect only 2 bells, we make the 2 bells which are dodging instead make a place. Let's try the exact same calls for plain bob doubles. This leads to the same number of bells being affected, but causes us an issue. This change is known as the identity change, where all bells stay in the same place. This sort of change is not typically used as it leads to repeated rows. Unfortunately, any other way to swap around 2 bells with a single requires a jump change, so a single which only affects 2 bells is not possible. We instead compromise and have a single which affects 3 bells. These sorts of reasons mean that the rule of a bob affecting 3 bells and a single affecting 2 bells don't always hold, especially when using fewer bells. I haven't gone into detail about what you do at a single in plain bob doubles, as it isn't used much. However, the strategy to work out what you do at each lead given a call is the same as for a bob, and I'd highly recommend you work through it on a piece of paper. There are rules used to work out what you do at the lead end change in most methods given a bob or a single. If, in a plain lead, you have a bell making a place over the treble and no other places at the lead end change, you will have a near call where places are made near the treble. This is what we had earlier for plain bob. If you instead have a place at the back, you have a far call. This is what the near and far calls look like. These rules don't apply to all methods, and there are also less common types of calls such as a big bob, but the 2 covered here are the most common. Something I want to stress is that most compositions are on methods with at least 6 bells, which is why some rules are more complicated on lower numbers of bells. However, I hope this video gave you a good understanding of the principles at play. I also haven't mentioned splices at all. That's a topic for another video. That's all I wanted to cover today. I know it's a lot of information, so if you didn't understand everything the first time round, feel free to watch it again, perhaps working through what I'm doing on paper. In the next video I'm going to take it down a notch and look at place notation. If you found this video useful, please do share it with others, and check out my Outcam partner for more ringing fun. Have a lovely day.